Welcome to exercise 2, and this is an exercise in doing integrals by hand. Okay, we're going to work through parts A and B of exercise 2 in this video. Okay, so starting with part A here, we've got a definite integral going from 1 to e, and you might notice that this integral is well suited to a u substitution. Okay, in particular, if we let u equal 1 plus ln of x, it kind of gets the ball rolling nicely for us, since 1 plus ln of x is the inside of a function. And so let's see, if we make that choice for u, du is going to be the derivative of that, which is just 1 over x dx. Okay, and then we can go ahead and solve for the dx by multiplying both sides by x. So we get x du is equal to dx. All right, and let's see what that does with our integral. Okay, if we substitute the pieces in, so our starting point, we'll just rewrite our integral. Okay, and looking down here, 1 plus ln of x, we made the choice to call that u. So we're going to get 1 over x times u squared, and then the dx, we can see from our work up here that dx is equal to x times du, so we'll go ahead and fill that in. Kind of what we're hoping for is some cancellation maybe, and you can see that we get it. We've got an x in the numerator and the denominator, so those two pieces are going to cancel. Okay, so rewriting our integral, we've got 1 over u squared du. Okay, we can rewrite that 1 over u squared as a u to the negative 2 if we take that u squared and move it up. So all we really need is the power rule to take an antiderivative here. We're going to get, let's see, u to the negative 2 is going to become u to the negative 1 over negative 1. Okay, evaluated between x equals e and x equals 1. Okay, and then just to help us to calculate this integral, how about if we take that u to the negative 1 and move it back into the denominator? Okay, we'll do that and also plug in what the u is equal to. So this is going to turn into a minus 1 over u, which is 1 plus ln of x. Okay, and then we're going to plug in our limits of e and 1. All right, let's see what we get here. So if we plug in the upper limit of e, we get minus 1 over 1 plus ln of e, then minus a negative, that's going to turn into a plus 1 over 1 plus ln of 1. Okay, last step, to maybe just notice what these numbers are. Ln of e is really 1, and ln of 1 is 0, so if we fill those in, we're just going to get minus 1 over 1 plus 1 is 2, and then over here 1 over 1, 1 plus 0. And finally, we're taking negative a half and adding it to 1. That's going to give us 1/2 for our final answer. Okay. So that's part A. Let's take a look at part B. Okay, and in part B here, you might look at this and try a u substitution, but you'll discover pretty quickly that u substitution just doesn't appear to be the way to go here. So what other tools do we have to do integrals? Well, you might remember integration by parts was one of the first things that we studied. Okay, let's give that a try here. All right, so I'm going to let u be ln of x, okay, since it has a derivative that's easy to calculate. So if we make ln of x u, then dv would have to be the remaining part of the integral, square root of x dx. Okay, and let's see, then we've got our u and our dv, so we need to calculate a du and a v, and derivative of ln of x is 1 over x. And to get from dv to v, we need to take an antiderivative, so remember that the square root of x is really x to the 1/2. Okay, if we take an antiderivative of that, we're going to get x to the 3/2 divided by 3/2, which we can rewrite as 2/3 x to the 3/2. Okay, so there's our v. So if we start with the integral that we were given and just rewrite it, Integration by parts formula looks like uv minus the integral of v du, so we'll fill in the pieces there. uv is going to look like, let's see, we need to put those two pieces together, so 2/3 x to the 3/2, there's the v, and the u looks like ln of x, so there's uv. And let's see, integral of v du, there's the v, and du looks like 1/x dx. And what we're hoping for is that the integral that we're looking at here is something that we can actually evaluate. It looks a little bit ugly, but it's not as bad as it looks because we can do a little simplifying there. All right, so let's start by rewriting the first part of this. Okay, we've got a 2/3 that we can pull out of the integral. And then what's left over is an x to the 3/2 and a 1/x. Okay, if you kind of subtract exponents there, x is really x to the 1. So x to the 3/2 minus 1 would give us x to the 1/2. That's what we really have inside this integral after we simplify that. Okay, almost there. Okay, now we just need to integrate x to the 1/2, and we actually did this calculation a minute ago when we went from dv to v. Antiderivative for x to the 1/2 is x to the 3/2 over 3/2, which if we multiply by the reciprocal is just 2/3 x to the 3/2. Okay, and maybe do one little simplification and we're done here. So 2/3 times itself is 4/9. Okay, and my writing's a little sloppy here. Let me correct that. Okay, and there would be an answer for us. Okay, and we are done with A and B.